Hi, welcome to the third edition of my A-level bridging topics between GCSE and A-level. So trying to give you tips and hints about what you would expect to see at A-level, and just trying to see the things you might continue to work on if you're sat at home and you're thinking, what can I do to help me really? This next one is about equations and inequalities. So again, as usual, just make sure you're commenting, let me know how you're getting on, tell me if I'm going too slow or too fast, and obviously any topics you want me to cover, happy to do that. Okay, so in this question, you can see there is a linear equation and there is another equation with squares in them, which actually, this is because there's y and x squared, it's a circle equation. It doesn't really matter if there's 1x squared or 2, you'll see in a second that it won't make a difference. Now you can have these at GCSE, but it's not that common, and people do often not understand it so well. So what you have to do is rearrange always the linear equation, so that it's always y equals or x equals. It doesn't matter which one, really. However, what I would suggest doing is, if you look at the second equation, there's 2 x's and only 1 y, so I would make this y equals something. Okay, so that's my suggestion. Okay, so if I rearrange it, I end up with y equals, and then 3x will become positive 3x, and then you'll take over the minus 2. So now I've got a formula there. 3x minus 2 is y. What I want to do is substitute in this y into what I've made it to in this one. So what that does is it replaces any y value with just 3x minus 2, because y actually does equal that. Okay, so then you end up with 3x minus 2, and obviously it's y squared. You'd square, but you have to make sure you square both. You square the whole thing, not just partially. Really easy to just jump straight ahead. Okay, so we leave the second half, but if I expand out 3x minus 2, end up with 9x squared, and then minus 12x plus 4. So I'm going to put that here. So 9x squared minus 12x plus 4. And then I'm going to just add on what else is in my equation. So I just did that quickly, that 9x squared. Hopefully you can see that 3x times 3x is 9x squared. And then minus 2 times 3x, you get minus 6x. And then it's the same again. So 2 lots of minus 6x. That's minus 2, 12x. And then minus 2 times minus 2 is positive 4. So hopefully you saw that, otherwise that's just running through that again. And then you can rearrange here. You've got 9x squared minus 6x squared. So you end up with 3x squared. Put the x's together, so minus 12x minus 13x plus 4. And then I'm left with a quadratic. Now the reason I'm left with a quadratic is that you will end up with 2 answers, and that is because, if you imagine, this is a circle, so you've got your circle and you've got a line that goes through it, and it will simultaneously go through that circle. I mean, it might not look anything like that, but it will go through that circle potentially twice, and it only doesn't go through it twice when it's on a tangent, or maybe it's away from that. Okay, but in this occasion, simultaneous, it does go through it, and it will go through twice. And then we can look to factorise. Now, does it factorise? Well, 3 times 4 is 12. So we need a number that multiplies to get 12 and adds to get minus 13. Well, we can do that because to get 12, to multiply to get 12, minus 12 times minus 1. And that will also add to get minus 13 over 3. So you end up with minus 4 over 1. If you haven't seen this method before, I've got a video on it, but it's just the harder factorising. So you end up with those. And those are my brackets. X minus 4 and 3x minus 1 equals 0. And so my x values will equal 4 or x equals 1/3. Now what you have to do here, you've actually got two values of x now, one value of x, two values of x. You now have to substitute these values in, so you'll get two answers. You'll get an x equals 4, and then a y equals for that value, and then you'll get an x equals 1/3, and then you'll get a y value for that one as well. So you will actually end up with two sort of things. Now if you look at x equals 4, let's put it into the easiest equation, and you can use the rearranged one. I'm going to use this rearranged one. So if x is 4, 3 times 4 is 12, minus 2 is 10. So then y equals 10 in this case. So that's sort of a set, that's a coordinate. So x is 4, y is 10. That's a coordinate there. And then the next one is a third. So if x was a third, 3 times a third is 1. 1 minus 2 is minus 1. So I've got two coordinates. The first coordinate is 410, and the second coordinate is a third minus 1. And basically they're the coordinates where the line, this line, and this circle cross. Okay, that's all what simultaneous equations is all about. You can do it algebraically, like I've just done here, or you can do it by sketching and drawing it out if you wanted to. It will be exactly the same answer. Okay, these are very good answers, actually, quite nice round numbers. Okay, so that's that, and again, that is in GCSE, but it is something that comes back with a vengeance slightly with A-level, slightly harder questions, etc. Okay, so moving on. Okay, I've got a curve, has an equation x squared minus 4, and a straight line has an equation. Again, you've got a curve and you've got a line. In the space below, sketch C and L on the same axis. Now, what you kind of need to think about, I'd always try and, if I was going to plot them, I would do a little graph. It's entirely up to you actually how to do this, x and y here. Or you could rearrange it so that y equals minus 3x. So you know that this one, there's no constant, so it goes through at 0, and you know it's got a gradient of minus 3. Or you could just plot the numbers in. So if I've just got some numbers here, so x minus 2, x at 0, x at 2, x at 4, I'm just making up some numbers. So if x is minus 2, y is going to be 6. If x is 0, y is going to be also 0. If x is 2, it's going to be minus 6. And if x is 4, that's going to be minus 12. So that's our line. Okay, you can see it's going up, and it's got a gradient of 3. It's going, sorry, gradient of minus 3. It's going down in 3s. Obviously, I've got gaps there. Okay, so that's my. I've just quickly done that there. If I wanted to, I am sketching, but it can help to do that if you want to. And this one is a quadratic, and it's a if you notice, it's a difference of 2 squares. And what that means is it's got, if it's got 2 brackets still, and it's cancelled out. So minus 2x is 2x, and then plus 2x. So they cancel out. So you end up with x squared minus 4. That's a difference of 2 squares. Again, that's really, really important you understand what that is and that means. So I can start by just drawing out that one. So that goes through at 2. It also goes through at minus 2. And it's going to go through the y-intercept at minus 4. It's actually right in the middle, isn't it? So it's going to be like that. So that's my x squared minus 4. If you know your graphs better as well, x squared is always going to be right dead in the middle. And minus 4, you're just moving, you're just transferring it down 4 places. That, again, the transforming graphs is really, really important. You know how to do that as well. Okay, and then the line is going to be a gradient of minus 3, and it's going to go through at 0. So for every one, it's going to go down 3. So 1, 3, 2, 6, and a bit like that. I haven't got a ruler or anything here, but you kind of hopefully get the gist of this here. It's going to look a bit like that. Okay, and it just says, this first question just says sketch it. So really working out what they'd look like and sketching is all you really need to do. Okay, let's look at the next question, because this is just an A part. The curve has equation this and the straight line has equation this. Write down the coordinates of the points at which C meet the coordinate axis. Now, all you have to do here is the line, the C, which is saying curve C is this one. So where does it meet the coordinate axis? Well, you kind of looked at that before. You know that the y-axis is going to meet at -4, and it's going to meet here at -2 and 2. So to write in the coordinates, it will be the y would be x would be 0, -4, and then obviously you'll have -2, 0, and 2, 0 as well. So that'll be our 3 coordinates where they meet, where it says the coordinate axes. Okay, we kind of did that, the working for that a minute ago, but it's just actually writing the coordinates down, understanding what they are. Okay, so that's question B on that one. And question C would be using algebra now, so nothing to do with the graph. Find the coordinates of the point where L intersects C. So this is C, this is L. Now you need to find the intersect, which basically means you need to do them simultaneously. Now for this one, you can actually, because both y, you can make this is another way of doing it, although you could do it how we did it earlier. Y equals x squared minus 4, and then also in this one, if I rearranged it, y also equals 3 minus 3x. Sorry, I've just rearranged that. And so if we know that both equal y, we can then make them equal each other. So that x squared minus 4 equals minus 3x, and then rearranging, I end up with x squared plus 3x minus 4 equals 0. And that ends up with a quadratic. Again, a quadratic that we can factorise. So you've got two numbers which multiply to get to -4 and add to get +3. Well, I can do +4 and -1. Hopefully you can see that by now. We need to be really understanding how to factorise. And it doesn't want anything else other than it's got find the coordinates of the points at which L intersects C. Well, it's going to be x is going to equal 1, or x is going to equal -4, and then we substitute either of those in, similar to what we did before. So if we've got the x value, and we know that y plus 3x equals 0, if we substitute in to x, or the 1, so y plus 3 times 1 is 3 equals 0, y equals -3, so y equals -3, and then in the second case, y plus 3 times -4, -12 equals 0, so if y minus 12 equals 0, y must equal 12. So then we've got again two coordinates. Well, for this coordinate here should be -4, 12, and this coordinate over here, which would be 1 and -3. Hopefully you followed that. But unlike the last one where we substituted in what y equals, you can do that, but I kind of have done that. If you think about it, I've just created it y equals -3x, and I've substituted it in for the y here. It's kind of the same thing, really. But I just want to explain it slightly differently. If you make them both equal the same letter, you can then make them equal each other exactly the same. Okay, so hopefully that was quite clear on that question. That's another simultaneous question. All right, now here again, you wouldn't see a question that looks like this on the GCSE, but it's not massively far away from what you can do, especially if you can do your simultaneous. Okay, so in this diagram shows the curve with the equation y squared equals 4 and then brackets x minus 2, and the line, so it's got an equation here, an equation here. We've got one with a curve and one with a straight line, which you can see in the picture. The curve crosses the x-axis at point A and the line intersects at P and Q. So the first thing you need to do is find A, okay, which is here. So all you need to do there is, if you think about this curve here, which is this first equation, at that point the value of y is going to equal 0. So what you need to do is substitute in the value of y being 0. So I substitute in here 0. 0 squared is just going to be 0, equals, and I'm just going to expand this out here, 4x minus 8. I've just expanded that side, and then therefore 8 equals 4x, and x would be 8 over 4, which is going to be 2. So the x here is going to be 2, and obviously the y, because it's going through the x-axis, will be 0. Okay, again, that's a substitution. It's just understanding when it goes to these coordinate axes, the value of x is and the value of y when it's going through there. Okay, find using algebra the coordinates of P and Q. So P and Q are where they cross, so therefore simultaneous. Okay, so we're doing exactly what we did before. I'm going to just get rid of that for now because I'm going to need there's some space on here. I'm just going to leave the answer there for you. It's a P and Q, so I want to know when they equal each other. Looking at this, what do I want to actually do? Well, if I make, in this case, I might make x equal something and then substitute in x, because then I don't need to worry about the square. Okay, so for this equation, I'm going to rearrange it so that it's x equals. So that will be 2x equals 3y plus 12, and then x equals 3 over 2, so 3 over 2y plus 6, dividing them all by 2 there. Okay, so then I need to substitute this part in as x is in this equation. So y squared equals, let's think what the best way to do this. So, and then x is going to be 3 over 2y plus 6. So that's like that, minus 2. Okay, so y squared equals, and then 4 times this first section. So 4 times 3 over 2y is going to be 12 over 2, which is going to be 6y. And then 4 times 6 is 24. And then 4 times minus 2 is minus 8. And I end up with something that looks like that. And then what I want to do is rearrange it. So that y squared minus 6y, and then plus 24 minus 8 is going to be 16. So I'm going to do minus 16 equals 0. See, I've got a quadratic now. I'm just looking to see if I can factorise this quadratic. So let's have a look at it now. So y squared, to get minus 16, 8 and 2, yes, I can do that. So I'm left with, where's y? And then minus 8, and then y plus 2. See that, you can see that will get me minus 6. So y is going to equal 8, or y is going to equal minus 2. Okay, and then again we're going to substitute those numbers in. You can actually substitute them into any of these. I'm going to substitute them to this first one because I don't really want the fractions. So I'm going to substitute them into this one here. So 2x, I haven't got a pen, 2x minus 3 times 8 24 equals 12. And then that'll be 36 equals 2x, so therefore x equals 18. So my first, when y is 8, x is 18. And then doing the other one, I'm running out of space here, sorry. 2x and then minus 3 times minus 2. So minus 3 times minus 2 is positive 6. So plus 6 equals 12. And then 2x is 6, so therefore x is 3. So that's our next coordinate. So our coordinates, which I'm going to just write up here, x is going to be 3 when y is 8. And then my second coordinate is x is going to be 18 when my y value is minus 2. And you can see which one's which, because my two positives are going to be my two positive coordinates. So 3, 8 is going to be this one. It's going to be 3, 8 up there. And down here is going to be where x is minus 2, although that doesn't make a lot of sense, does it? Did I do that the wrong way around? Yes, I did that wrong way around. Sorry. See, it's easy to make mistakes, but if you look at the picture, it'll become clear. It's because I'd run out of space. Okay, so y equals 8. When y equals 8, x was 18. So that's this one, 8 and 18. And then when y was minus 2, x was 3. So that makes loads more sense. So x is 3. The pictures will always be right. If you end up doing exactly what I did and pick the wrong one with the wrong thing, then you might spot it by putting it in the picture. That's why it's actually really important to make sure the picture is done as well. And then 3 and minus 2. Okay, so that's the coordinates of those two there. So hopefully you can see that. Again, you wouldn't have this at GCSE, but there's nothing saying that you couldn't do the same thing. It's still simultaneous using quadratics. Okay, next question is a quadratic, but it's got an inequality greater than 0. So this is where we're going to look at inequalities and practice that a little bit as well. So x squared minus 7x minus 18. And you might notice that you can factorise this, because minus 18, you can get minus 9 plus minus 9 and plus 2, which will then equal minus 7 greater than 0. And then the values of x are 9 and then x are 2 greater than 0. And if we look at this on a graph, we'll end up with 2 and 9. Okay, so our quadratic will look like this. It's quite straightforward. And then no, that's wrong. Sorry, equals minus 2. So you end up with, sorry, so it's very easy to make little errors like this. I'm trying to rush through, that's why. Sorry, minus 2 and 9. So you end up a bit like that. And it goes to minus 18 as well. That's actually why I spotted it was wrong. Okay, so it looks a bit like that. And we're saying that the quadratic is greater than 0. So that means that anything above the line now, greater than 0, is what we actually need to think about. So it's all these numbers and anything there. So it's a split inequality. So x is going to be greater than 0 when x is less than minus 2 and also greater than 9, because anything, if you think of this as a number line, anything kind of in between there, and it's going to be less than 0, but actually we were interested in anything above 0. So anything that's less than minus 2, greater than 9 will satisfy this inequality of it being greater than 0. Okay, so hopefully you followed that. That's quite a straightforward quadratic, but it's just understanding that you need to split the inequality sometimes. rather than it just being a continuous underneath generally. Okay, we'll do one more question. So find the set of values for x, which is here. Again, these are not something that you wouldn't potentially see at. I just wanted to make sure you were okay with them. But I think if you did the last one, this one will be very, very straightforward. So when you're doing inequality, you can rearrange it so that 4x minus 3 is greater than 7 minus x. You can rearrange it so that you'll have 5x on this side, minus 10. Oh, maybe I want to do that. So then x is greater than 2. So in that case, x is greater than 2. So that was just A. All I did was rearranged it really, and so that x on one side, the numbers on the other. I don't know why I put 10 over there, but don't worry about that. Okay, and the next one is a quadratic again, but it's a harder quadratic, so you might have to think about it a little bit more. So if we do our cross, so 12 times minus 12 times 2 minus 24 and a minus 5. Can we factorise? So can I find two numbers which times to get minus 24 and add to get minus 5? Well, 12 and 2 doesn't work. You can write these down. 12 and 2 doesn't work. 6 and 4 doesn't work. What else goes in it? Oh, 8 and 3. Oh yeah, there we go. 8 and 3. So it's going to be, because it's minus 5, it's going to be negative 8 and a positive 3. So 8 and 3 all over 2. This one goes down to 4 over 1. Again, this is something we did this a bit more in more detail before this, factorising harder quadratics. If you're not sure about how to do it, there's loads of methods. This is just one method I like to use. So my brackets here would look like 2x plus 3 and x plus 4. Okay, and that is less than 0. So, and that will end up with, if it's less than 0, if you think about this as a quadratic, 2x plus 3 would be 3 minus 3 over 2 minus 3 over 2 and minus 4. Oops. Something's gone wrong there. I'm doing something wrong. Oh, it was minus 8. This should be minus 4. Sorry, it should be positive 4 over here. So it looks like that. It goes down to minus 12, up like that. And it's going to be less than 0. So it's going to be between here and here. So I'm just going to put down here. X is greater than minus 3 over 2, but less than 4 if it's to satisfy this less than 0 part. This is the underlined bit here, because it's a less than 0 equation. So it's between here and here, and then obviously x is greater than 2. If you look at C, it says what set of values satisfy both this one and this one. Well, if it's got to be greater than 2 and then less than 4, it's going to have to be x has to equal 3 to satisfy both. Satisfy both equations. Okay, so hopefully you can see that. That was just two. That's kind of a linear one. Was greater than 0. Sorry, greater than 2. It has to be greater than 2, x, but it has to be between minus 3 over 2 and less than 4. Therefore, the only number that is greater than 2 and less than 4 is 3. If you were to satisfy both of them equations. Okay, so hopefully that's helped giving you an idea of what you can see. This is actually, this one particularly, you may have found in at GCSE, but essentially this is an AS paper, so you will need to brush up on it if you're not sure. Okay, so if you've enjoyed the video, it's helped a little bit, and then please subscribe. I'll be posting more videos similar to this and others as well. Please comment down below if you've got any suggested videos or anything you're not sure about. If there's anything I've done wrong, you know, I do rush through this sometimes, and it's easy to make mistakes, so I'm sorry if that's happened. Otherwise, I'll see you soon.